Alright, before we start today's lesson, we'll be required to solve the problems that I left you with in the last lesson, which is to sketch the graphs of a few curves. So let's look at the few curves that we have to do. So I'm required to sketch the graph of f of x equal to x squared plus 2x minus 8. Let's write that in vertex form first off. So given this, then we know that f of x would be equal to x squared plus 2x plus 1 squared minus 1 squared minus 8. F of x would be equal to perfect square over here, so that is x plus 1 squared. 1 squared is equal to 1. Negative 1 minus 8 would be negative 9. So that's the vertex. So the turning point is negative 1, negative 9. The value of a is greater than 0, and in this case a is equal to 1, so the turning point is a minimum point. So that turning point that we identified over here is a minimum turning point, so that means the curve should look something like this. Erase that. Right. Okay, so we identify the turning point. We identify that the turning point is a minimum point, and the next thing we need to do is we need to identify the intercepts. The y-intercept occurs when f is evaluated at 0. F of x is equal to x plus 1 squared minus 9. So f of 0 would be equal to 0 plus 1 squared minus 9, which is 1 minus 9, which is minus 8. So the y-intercept is 0 minus 8. The x-intercepts occurs when f of x is equal to 0. So that means x plus 1 squared minus 9 is equal to 0. That means x plus 1 squared is equal to 9. That means x plus 1 is equal to plus or minus 3. And that means x is equal to minus 1 plus 3 or minus 1 minus 3, which means x would be equal to 2 or negative 4. So the x-intercepts are, that would mean 2, 0, and negative 4, 0. So my points are as follows. We have negative 1, negative 9, minimum. So negative 1, negative 9, a minimum, min. We have this y-intercept, 0, negative 8. And then we have these values here. We're looking at the x values, and we notice that the x values run from, let's see, 0 to 2 to negative 4. So, okay, so we need x values that go from from negative 4 to 2. And then when it looks at the y values, we're seeing that the y values goes to negative 9. So we need to have the curve a little bit like this. All right? So this here will be my f of x. This here will be my y. Now, here's why I'm doing it like this. Now, we need to go from 0 to 2. So this here will be 0, this here would be 1, and this here would be 2. Then we go this way, and this would be negative 1, this would be negative 2, this would be negative 3, and then this here would be negative 4. All right? Then with respect to f of x, we have nothing above the axis, everything is below. So we have to go here, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, and then negative 9. And then let's see if we can put some values in on this. So we have 2, 0, which is the first point, and I'll just put it in red over here, 2, 0. And then we have the point negative 4, 0, which is over here. We have the intercept, which is negative 1, negative 9, negative 1, negative 9, which is down here somewhere. Then we have 0, negative 8 as the y-intercept, which is over here. I can do a reflection, and I can see that it's about negative 1, so it's going to be right here, this negative 2, negative 8. So I do that reflection over here, so I have a reflected point. And now I can just simply draw my line going from one to the next. So let me just draw my line. So I'm going here, 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 here. Again, don't look at the line. Look at the point you want to go to. I started looking at the line around here. All right, so that would be the curve. That would be what the curve approximately looks like. And let's go on to the next one. Given f of x is equal to minus x squared plus 6x minus 5, then rewriting to vertex form, we get, and that is f of x is equal to minus, open bracket, x squared minus 6x, close bracket, minus 5. You know what, let me just put this in the same bracket here. All right, then we're going to do the separation in the middle. So f of x is equal to minus, open bracket, x squared minus 6x. And we're going to have plus negative 3 squared, and then minus negative 3 squared. And then we're going to close that bracket on minus 5. So then we have f of x would be equal to x minus 3, close bracket with a negative sign outside, squared. Then we're going to have negative 3 squared is 9, negative 1 by 9 is negative 9. Negative 9 by negative 1 out in front here is going to give me a positive 9. So it's positive 9 minus 5, which is simply a positive 4. And that's our function. So the turning point is, and I'm going to put that turning point here, of 3, 4. We see that a is less than 0. So the turning point is a maximum point. The y-intercept occurs at f evaluated at 0. So f of x is equal to negative x minus 3 squared plus 4. F of 0 would be equal to minus of 0 minus 3 squared plus 4. So minus 3 squared is going to give me 9. Negative sign in front of here is going to make it a negative 9. Negative 9 plus 4, negative 5. So this here would be equal to negative 5. So the y-intercept is, and you can see 0, negative 5. Next, we need to figure out the x-intercept. So the x-intercept occurs at f of x equal to 0. I should say occurs when f of x is equal to 0. So f of x is equal to negative, open bracket, x minus 3, close bracket, squared plus 4 equals 0. And I'm just going to take the other section over here and move from there. So minus, open bracket, x minus 3, close bracket, squared is equal to minus 4. And then we have here x minus 3 squared would be equal to positive 4 because I'm going to divide both sides by negative 1. Then I'm going to have that x minus 3 is equal to the square root of 4 plus or minus. And this here with plus or minus 2. And then x would be equal to 3 plus or minus 2, which means that x could be equal to 3 plus 2, which is 5, or x can be equal to 3 minus 2, which is 1. So the x-intercepts, are, we have 5, 0, and 1, 0. So let's draw the curve now. So we're going to look at the point. So I'm going to have that point up here. That 3, 4 is a max point. So I'm going to write that down. 3, 4, and I'm going to put the word max here. And then I'm going to have my other point down here, which is this 0, negative 5. That's my y-intercept. 0, negative 5. And then I have my 2 points remaining at the bottom down there. So let's see. Our lowest x value. So this is my function curve here. So my lowest x value is going to be 0 and my highest is going to be 5. So everything is on the left-hand side, the right-hand side of the curve. Then I'm going to look at my y values, and my y values are 0 to negative 5. Oh, 4 is the max, and negative 5. So I'm going to have to do right in about the middle around here for this one. So I'm going to do it here like that. This is going to be x, and I'm going to put the points for the function. So I'm going to go to 4 on the top and 5 on the bottom. So I'm going to see here 1, 2, 3, 4, and then I'm going to have negative 1, negative 2, negative 3, negative 4, and then negative 5 at the bottom. 0 is in the center over here. And then I'm going 0 to 5. So I'm just going to say 1, 2, 3, 4, 5. So let me put the points on the graph now. So I have 5, 0, which is here. I have 1, 0, which is here. So these are my roots. I know it's a max curve, and we have 3, 4 at the turning point. So 3, 4 at the turning point here. Let me just draw a little dotted line so you can see it going from 3, 4. Then we have 0, negative 5, which is over here. And we're seeing 1 away, so I can estimate somewhere where 6 would fall, and I can see 6 would fall approximately around here. So I can put a reflective point right about here, so, right? And that would be able to give me my curve. So watch the point and not the line. The point and not the line. All right? Do it slow and steady, you'll get it. Eventually, you'll be able to do it faster. Right, so that's the curve for that one. Let's go on to the other one. So we're saying given that 2x squared minus 4x plus 1, then rewriting in vertex form, we get f, you know what, I forget the f of x part here. F of x is equal to 2 into x squared minus 2x close bracket plus 1. Then put it inside of the bracket, so we have 2 into x squared minus 2x. We add 0, so that is plus negative 1 squared minus negative 1 squared, and then close that bracket, and then we add the 1. And then we finish the rewrite. So I'll have 2 into x minus 1 squared. This minus 1 squared is going to be 1. 1 by minus 1 is going to give me minus 1. Minus 1 by positive 2 is going to give me minus 2. Minus 2 plus 1 is going to give me minus 1. And that's our function. So the turning point is negative h is going to be 1, k is negative 1. And then we're going to do another one, which is to determine the max. Since the value of a is greater than 0, and in this case a is equal to 2, then the turning point is a minimum point. And in this case, that minimum point looks like that. Next, the y-intercept occurs when f is evaluated at 0. I should say at f of 0. F of x would be equal to 2 into 0. Sorry, f of 0 would be equal to 2 into 0 minus 1 squared minus 1. All right, so minus 1 squared is going to give me positive 1. Positive 1 by 2 is going to give me 2. 2 minus 1 is going to give me 1. So the answer here is 1. So the y-intercept is 0, 1. The x-intercepts occur when f of x is equal to 0. F of x would be equal to 2 into x minus 1 squared minus 1 equals 0. I'm just going to work with this part here from now on. So we have that 2 into x minus 1 squared is equal to 1. X minus 1 squared is equal to a half. X minus 1 is equal to plus or minus a half. Root of a half, I should say, which is, well, let's leave it at that. And then x would be equal to 1 plus or minus the root of a half. So the x intercepts 1 plus root of a half, 0, and 1 minus root of a half, 0. Alright, so let me write those points. The max here was, the turning point was 1 minus 1, and it's a min. So we have 1 minus 1, and it's a min. And then we have 0, 1, and that's the y-intercept. So we have 0, 1. Let's look at the function graph now. So looking at the x-axis, we're seeing that the minimum value is going to be 0. The maximum value is going to be 1 plus the root of a half. All right? So that means we're only on the positive side of the x-axis. Let's look at the y-axis. The y-axis is showing me 0, -1 to +1. So, okay, we don't have much to do. So, come here, here, this is our function, and I only need this part, and it's evenly distributed on either side of the x and the y, right, good. So now I have 0 here, I have a +1 up here, and I'm going to make it big this time, so +1, and I'm going to have a -1, because most of the things seems to be happening on that graph, there. So let's see now. We have going all the way from 0 to 1. So I'm going to say 1 is approximately around here, right? And I'm going to say a little bit below 1 is 1 minus the root of a half. And then a little bit above the 1, same amount of space on either side of the 1 is going to be 1 plus the root of a half, right? I don't need anything else. Let's plot those points now. So I'm seeing here I have positive this side with 0, so that's here. And then I'm seeing the next one, which is here. Then the midpoint, which is 1, -1. So 1, -1 is this one here. That's that point. And then we have the 0, 1. 0, 1 is over here. And then the reflective would be at 2. So I'm just going to put the 2 over somewhere around here. Imagine it to be around here. Matching with this 1 over here. So that here. Right? Remember, we're going along the line of axis of symmetry there. Okay, so that should be the curve, and we just simply draw the curve from point to point with that. Right? You can use your ruler and make the spaces a little bit more even as much as you want, but quite frankly, just as long as you approximate it evenly, that's good enough, because remember, you're doing sketches. Okay, so that's the last solution, and let's go into today's lesson, which is to determine the nature of the roots using the discriminant. All right, today let's continue with our additional math series. Today we're going to determine the nature of roots of a quadratic equation using the discriminant. So let me just put the topic, sorry, garbage truck in the background. So nature, theory of the roots of a quadratic equation. All right. What we're going to do is we're going to get started from the general form of a quadratic equation. So remember, our general form of our quadratic equation is ax squared plus bx plus c equal to 0, where your a, your b, and your c are members of the set of real numbers, and a cannot be equal to 0. So you should already know that in the equation, a, b, and c represent the coefficients, and x represents the variable. The key to determining the nature of the roots lies in the discriminant denoted by the symbol d. So this here is the symbol used to denote the discriminant, and I'll just put that word, discriminant. And the equation is as follows. It's b squared minus 4ac. The value of d tells us about the roots of the quadratic equation without actually solving it. Here's what the discriminant indicates. If d is greater than 0, the equation has two distinct real roots. So if d is greater than 0, let me just put this over here, actually. If d is greater than 0, then the equation has two distinct real roots. Else, if d is equal to 0, then the equation has two equal roots. And then else, if d is less than 0, then the equation has two complex conjugate roots. And this just simply means that we don't have any real roots, meaning the roots are not real roots. All right, so when you're solving a problem and you get the discriminant being less than 0, you just simply need to say this. The roots are not real roots, or you can say there are no real roots, okay? Because what you will get is two complex conjugate roots. Now, we don't deal with complex numbers yet, so you would just have to say there are no real roots. When you go to CAPE level 2, then you'll be able to see complex numbers. Let's do some examples so you can understand how we would use this. So given x squared minus 5x plus 6 equals 0, then a is equal to 1, b is equal to minus 5, c is equal to 6. So d would be equal to b squared minus 4ac, which is minus 5 squared minus 4 into 1 into 6. 5 5s are 25, 6 4s are 24. So this is negative 4 by 6, negative 24, so minus 24, and we get 1. Since d is greater than 0, the equation has two distinct real roots. Let's try another one. So we say, given that x squared plus 2kx plus, open bracket, k squared plus k minus 2 is equal to 0, then a would be equal to 1, b would be equal to 2k, and c would be equal to k squared plus k minus 2. So d equal to b squared minus 4ac equal to 0. D would be equal to b, which is 2k squared minus 4 into 1 into c, which is k squared plus k minus 2. And that is supposed to be equal to 0. Simplify, well, expand, and we get that d would be equal to 4k squared minus 4k squared minus 4k plus 8 equals 0. So I just simply take this and this, I get minus 4, and then this minus 4 by this minus 4 by this with the distributive law. Alright, then that means that d would be equal to minus 4k plus 8 equals 0. Now we need to solve for k. We know that this is equal to this, which is equal to this. So we're just going to take this section here. And we're going to say 4k plus 8 equals 0. Minus 4k is equal to minus 8. K would be equal to minus 8 divided by minus 4, which is just simply 2. So right away we're seeing there, therefore, that k is equal to 2. So we can substitute 2 for k inside of this equation here, and we can get the coefficients of this quadratic equation. All right, these are the different types of problems that you can get with the nature of roots equation, or the discriminant equation, I should say. Another thing that they could possibly do is that they can actually use a range of values, meaning that you can use a greater than sign over here. If they use a greater than sign over here, you would have to learn, you'll have to use your inequalities knowledge, and that we will do later on in the series. Let me give you some problems. All right, so these are the problems that you have to do. Thank you for joining me for this lesson, and we will continue with the lessons next week.